Welcome to our deep dive today. We're going to be talking about something pretty cool, something called electrochemiluminescence.
Or ECL for short.
Right, ECL. Basically, it's all about making light from electricity and chemistry.
It's really fascinating stuff.
And we've got a whole bunch of interesting sources on it here, journal articles, research summaries, all about ECL and all the cool things it can do.
Absolutely. It's amazing how many applications there are.
So if you're looking for something to spice up your next cocktail party conversation, this is it. Buckle up, because we're about to get bright.
Haha, yeah, that's a good one.
So picture this. You're at a party, and someone asks you, hey, what's electrochemiluminescence? Now, instead of boring them with some textbook definition, you just casually drop this fact. ECL converts almost 90% of electrical energy directly into light.
Yeah, it's pretty incredible.
Compare that to a measly 10% for like a regular old incandescent bulb. Mind-blowing, right?
It really is. That's one of the things that makes ECL so special, that efficiency. Unlike a light bulb, which, makes a ton of heat, ECL produces light directly from those electrochemical reactions.
So basically, we get pure light, no wasted energy on heat. That's pretty awesome. But how does that actually work in the real world? What are some examples?
Well, one of the most exciting areas is biosensors.
Biosensors.
Yeah, think of them like tiny little molecular detectives. They can snip out specific molecules with incredible sensitivity. We're talking about detecting things at concentrations so small, it's like finding a single grain of sand on an entire beach.
Whoa, that's hard to even imagine. Okay, but how do these biosensors actually work? Can you break it down a bit?
Sure, let's take food safety testing, for example.
Okay, food safety.
ECL biosensors can be designed to detect certain bacteria, like Salmonella, in food samples. When the bacteria hits the sensor, it triggers an electrochemical reaction that generates light. The brighter the light, the more bacteria there is.
So it's like if there's even a tiny bit of contamination, these sensors set off the alarm bells.
Pretty much. It's incredibly sensitive, so we can catch those nasty bugs before they cause any trouble.
That's definitely reassuring. But it makes me wonder, what else can we detect with these biosensors? Is it just bacteria, or is there more to it?
Oh, there's so much more. We can use them to detect biomarkers for diseases or monitor environmental pollutants. You can even analyze the composition of materials with them. The possibilities are almost endless.
Wow. Okay, I'm starting to see the potential here. But let's move on to another cool application, something I'm really curious about. Display technology. I've heard that ECL could be the future of screens. Is there any truth to that?
Absolutely. That same energy-efficient light emission we talked about, the thing that makes ECL great for biosensors, it works for displays too.
So we could have thinner screens, brighter screens?
That's the idea. And because they're more energy efficient, they'll use less battery power.
So my phone could last a week on a single charge? That would be a dream come true.
Haha, well, we're not quite there yet, but the potential is definitely there. Imagine a world with devices that have amazing screens, but they don't drain your battery in a few hours. That's the promise of ECL display technology.
It sounds amazing. I can't wait to see where this technology goes in the future. But for now, let's shift gears to something a bit more, traumatic. Forensic science.
Oh yeah, the CSI stuff. ECL plays a big role in that world, helping to uncover hidden clues at crime scenes.
Ooh, tell me more. How exactly is ECL helping detectives solve crimes?
Well, one of the most common uses is in detecting tiny amounts of blood or DNA.
Okay, blood and DNA.
Even if someone tries to clean up a crime scene really well, tiny traces of those biological materials can stick around.
Right.
Traditional methods might miss those faint traces, but with ECL-based techniques, we can amplify those signals, making them visible to investigators.
So it's like ECL is giving detectives a superpower, letting them see evidence that was practically invisible before.
That's a great way to put it. It's like having a secret weapon that reveals the truth no matter how hard someone tries to hide it.
Wow, that's what serious crime-fighting technology. But is it just blood and DNA, or can ECL detect other things at crime scenes?
Oh, it can detect all sorts of things, like fingerprints, even if they've been wiped clean. And things like explosives or drugs, too.
So it's helping to catch criminals and keep people safe. That's pretty incredible. It's amazing how ECL has such a big impact in so many different areas. But let's move on to our final ECL factoid for this part of our deep dive. Analytical chemistry.
Okay, analytical chemistry.
This one might sound a good technical, I know, but it's super important.
It really is. In a nutshell, analytical chemistry is about figuring out what stuff is made of, like identifying and quantifying the different components.
Right, breaking things down to their basic building blocks.
Exactly. And ECL is revolutionizing this field by providing incredibly sensitive and fast ways to detect those components.
Okay, but can you give us a real-world example of how this works? Like how ECL is actually being used in analytical chemistry?
Imagine you're a researcher developing a new drug.
Okay, a new drug.
You need to be absolutely sure that the drug is pure, that there aren't any harmful contaminants in it.
Right, safety first.
ECL-based techniques can analyze those samples super quickly and with incredible precision, ensuring the safety and effectiveness of that new drug.
So not only does it speed up the research process, but it also helps ensure those new medications meet the highest standards.
Exactly.
This has been an incredible journey so far. We've learned about how ECL can do everything from helping us detect those nasty bugs in our food to lighting up our screens and even solving crimes. And we've just scratched the surface.
There's still so much more to explore.
Stay tuned for part 2, where we'll dive even deeper into the fascinating world of electrochemiluminescence. We'll be back after a short break.
See you soon. Welcome back. We're diving deeper into electrochemiluminescence.
I'm ready for more ECL adventures. We've talked about ECL's ability to detect tiny amounts of stuff, but I'm still a bit fuzzy on the how. What's going on at the molecular level to create this light show?
It all boils down to a special kind of molecule called a luminophore.
Luminophore, okay.
You can think of it like a tiny little antenna.
An antenna.
Yeah, it absorbs energy and then, boom, releases it as light.
So it's kind of like what, a firefly in a test tube?
Sort of. But instead of using chemical energy like a firefly, we use electricity to get those luminophores excited.
Excited how?
We apply a voltage to a solution with the luminophore in it. This triggers a whole bunch of electrochemical reactions.
Reactions. Okay, walk me through it.
Basically, it's all about moving electrons around. The luminophore molecule gains an electron, which kicks it into a higher energy state, what we call an excited state.
An excited state.
Right, but it can't stay excited forever. So to get back to its normal brown state, it releases that extra energy, and that's where the light comes from as a photon.
So it's like those glow-in-the-dark toys. You charge them up with light, and then they slowly release it over time.
Yeah, that's a good analogy. Except ECL is way faster, and we have more control over it. We can actually tweak the reactions to get different colors of light.
Different colors.
And we can fine-tune how bright that light is, too.
Wow, that level of control is pretty impressive. But this all sounds very high-tech, like something you'd only find in some fancy lab. Is ECL just for scientists, or are there, everyday things that use it?
You might be surprised to learn that you've probably already encountered ECL in your daily life. Ever used one of those home pregnancy tests?
The ones with the lines that tell you if you're pregnant or not?
Exactly. A lot of those tests use ECS to detect those pregnancy hormones in urine. It's a quick, easy, and reliable way to get those results.
Wow, I had no idea. So ECL is literally helping people start families. That's pretty amazing. But what about other uses beyond, diagnostics? Where else might we see ECL making a difference?
Well, for instance, researchers are looking into how ECL could be used for monitoring the environment, detecting pollutants in water or air.
Water or air, got it.
It's way more sensitive than older methods, so we can catch those potential hazards early on.
So instead of waiting for a problem to, blow up, we can use ECL to spot it at the molecular level.
Yeah, before it even has a chance to become a bigger issue. It's a game changer for protecting the environment.
Definitely a game changer. But can we get even more futuristic here? What about, blowing plants? I've heard about scientists working on there. Is that ECL?
It's similar. Scientists have already made some glowing plants using bioluminescence.
Bioluminescence, okay.
It's the same process that makes fireflies and jellyfish glow. Combining that with the control we have with ECL could lead to some amazing sustainable lighting solutions.
Glowing trees lighting up our cities, that would be incredible. Okay, my mind's officially blown. But let's step back from the future for a second and get back to those medical applications. You mentioned pregnancy tests earlier. What other medical uses are there for ECL right now?
Oh, there are tons. ECL is revolutionizing how we diagnose diseases. It can detect biomarkers for all sorts of things. Cancer, heart disease, you name it.
Biomarkers, right? Those are indicators that something might be wrong.
Exactly. And since ECL is so sensitive, we can catch these diseases super early, which can make a huge difference in how well the treatment works.
Early detection is key, for sure. But is ECL just about detecting whether something's there or not, or can it tell us, how much of something there is?
It can do that too. It can actually tell us exactly how much of a certain biomarker is present, which is super important for personalized medicine. We can tailor treatments to each patient's specific needs.
Personalized medicine, wow. So ECL is playing a role in that. That's pretty amazing. But what about going beyond diagnostics? Can ECL actually be used to treat diseases too?
Well, that's something researchers are actively exploring. There's this thing called photodynamic therapy, which uses light to kill cancer cells.
Light to kill cancer cells, okay.
ECL could be a way to deliver that light in a more targeted way, so we're not hitting healthy cells.
So instead of blasting the whole body with radiation, we could use ECL to zero in on just the cancer cells.
Yeah, that's the hope. And that's just one example. There's a ton of potential for ECL in treating diseases, and we're just getting started.
All this is really exciting stuff. ECL is clearly more than just a cool science experiment. It's a powerful tool that can change the world.
I completely agree. From the everyday things we use to the big scientific breakthroughs, ECL is lighting the way.
I'm definitely feeling inspired to learn more about it. But for now, let's wrap up this part of our ECL journey and give our listeners something to think about.
If you're looking for a field that combines cutting-edge science, creativity, and the potential to make a real difference, ECL is definitely worth checking out.
I love that. All right, everyone, get ready for part 3, where we'll explore even more mind-blowing ECL applications and see where this technology is headed in the future. And we're back for our final deep dive into the amazing world of electrochemiluminescence.
It's been quite a journey, hasn't it? From tiny glowing molecules to crime scenes to, well, maybe even glowing plants someday.
Who knows what the future holds? But before we get too carried away, I wanted to touch on something we haven't talked about yet, the challenges, the limitations of ECL. Every technology has its downsides, right?
Of course, ECL is no exception. I mean, one of the big challenges is that those reactions, they need very specific conditions to happen.
Specific conditions?
Like the right mix of molecules, a very precise electrical potential, things like that. It's not always easy to create those conditions, especially if you need a portable device or you're working in a harsh environment.
So it's not as simple as just like plugging it in and expecting it to work.
Not always, no, but researchers are working hard to make ECL more robust and easier to use. They're developing new types of luminophores that are all stable, more efficient.
Ah, so the technology is still evolving. Still a room for improvement.
Absolutely. And as it gets better, we'll see even more creative and impactful applications. It's really exciting to think about what the future holds.
I can imagine. So where do you see ECL making the biggest difference in the future? What are some of the areas you're most excited about?
Well, one area that I think has huge potential is personalized medicine.
Personalized medicine. Okay.
Imagine a world where, your doctor could use an ECL-based sensor to keep tabs on your health, like in real time.
In real time.
Yeah, they could see tiny changes in your body way before any symptoms show up.
It'd be like having an early warning system for your health. Catch things before they become a problem.
Exactly. That kind of continuous monitoring could revolutionize preventive care.
Wow, that's pretty incredible. What other futuristic applications are on the horizon? Anything else that gets you excited?
Oh, there are tons. For example, researchers are working on biocompatible implants.
Implants.
Yeah, tiny devices that could be implanted inside the body, powered by ECL, to monitor and even treat certain conditions. Imagine, like a tiny device in your heart that could detect the first signs of a heart attack.
And then do what? Release medication?
Exactly. It could release medication right then and there to stop the heart attack in its tracks. It sounds like science fiction, I know, but this kind of technology is closer than you might think.
It's pretty mind-blowing. It seems like ECL is pushing the boundaries of what's possible in medicine and so many other fields. But let's say someone listening to this is really intrigued by ECL and wants to learn more, maybe even pursue a career in this area. What advice would you give them?
Well, the best place to start is, diving into the research. There are so many resources available online, scientific journals, educational videos, even online courses. It's never been easier to learn about this stuff.
So if you're passionate about it, just go for it, right? Dive in and explore.
Exactly. And don't be afraid to reach out to people who are already working in the field. Send an email to a researcher, ask questions. Most people are happy to share their knowledge and help others get involved.
That's great advice. It seems like the future of ECL is incredibly bright.
It truly is. It's an exciting time to be in this field, and I can't wait to see what amazing discoveries are just around the corner.
Well, that brings us to the end of our deep dive into the world of electrochemiluminescence. We've learned so much about the science, the applications, the potential of this incredible technology. I hope you've enjoyed the journey as much as we have.
Me too. It's been a pleasure sharing this with you all.
And to all our listeners out there, remember, stay curious, keep exploring, and who knows, maybe you'll be the one making the next big ECL breakthrough.